Good morning, my dear students. In this session, we will talk about the required quantities for moment distribution method. Okay, last session we have talked about the introduction. I mean, what is moment distribution method and how it is related to slope deflection method, and then what is the use of it and purpose of the moment distribution method. Okay, so this was the last session talk. At this session we will see some of the quantities which are required for carrying out the moment distribution method. Okay, so one of the quantities that are there are three quantities, three such quantities I have introduced in the index itself. So the syllabus what to study. So there you have seen carryover moment is the one, stiffness is the another one, and then distribution factor. Okay, these are the three quantities that are required for carrying out the moment distribution method. Okay, so to apply the moment distribution method, you must know these three quantities. Okay, then only we will be able to proceed for the moment distribution method. Okay, so what is carry over moment? Okay, let us see what is it actually. So when a moment is applied at one end, when a moment is applied at one end of a member, allowing rotation of that end and fixing the far end, some moment will develop at far end. Some moment will develop at far end. That is called as carry over moment. Okay, so if you see the picture, you will clearly get this definition. So we have a member AB. We have a member AB where one end is allowed rotation. So one end we have hinge means what? Rotation possible. Okay. So end A rotation is possible. Okay. Whereas end B rotation is not possible. Means you can see fixing the far end. So what do you call wherever you are applying moment, that we call as we call that end as near end. Near end. This one we call it as far end. FAR. Okay, not FOR. It is FAR. Okay, so far end. This is near end where you are applying the moment. So this is moment applied. So you are applying moment M, okay, at end A, and you are allowing rotation at that end. So when you apply the moment, the end will rotate by some theta, that is theta A. So what about the far end? Far end is fixed, okay. So that's why this will not rotate. So theta B is 0. Okay, theta A is possible, whereas theta B is 0. Okay, far end fixed. Far end is fixed. Okay, so theta B is equal to 0. Okay, so what happens when far end is fixed? Right, so you will have a reaction, right? So you have applied moment here, so you are trying to rotate this end. So if this is not fixed, what happens? So this is, if that is not fixed, so that should also rotate, right? This end also should rotate, which means, so there will be theta b possible. Okay, theta b is possible. When it is possible? When b is allowed rotation. So when you allow rotation at b, this will be the deflected diagram. Okay, deflected shape. Whereas what you are doing, you are fixing. So what happens when you fix? This theta, this dotted line should be straight here. Should be no straight line there. Horizontal line. It should not rotate. Means this line here should move to this position. Okay. So who will do that? This support will try to hold like this. Okay, because this is fixed, right? So if it is rotation is possible, when you rotate the far end, this also will rotate. Okay, so when you try to rotate this member, this end also will try to rotate. Now what is this? So you are rotating this end, and this end is fixed. Okay, so that is why. So if you want to know have zero theta here, you have to apply, say, when you rotate this one, this will also try to rotate. So what you should do, you should have to apply some resistance. That is what is m dash. Okay, so this is a resistance to this one. So how much resistance it will develop here, that resisting moment is called carryover moment. Got it? So when you take a member, one end is hinge, another end is fixed. So when you apply some moment at end A where hinge is there, it will be rotated by some theta. The far end will also try to rotate, but as that support is fixed, it cannot rotate. That is why resistance will develop reaction. So that reaction at fixed end is m dash, what we call. That moment develop at far end is known as carryover moment. So if we once again read the definition. So when a moment is applied at one end, here at A, when a moment is applied at one end of a member, allowing rotation of that end and fixing the far end, some moment will develop at far end. This is the reaction. Some moment will develop. Why that moment develops? To make theta be 0. To make theta be 0, you need this one. Okay. So to some moment will develop at far end. That is called as carryover moment. Okay. So how do you define a carryover moment now? When a moment is applied at one end, which is allowed rotation, and the far end of that member is fixed, some moment will develop at far end, which is called as carryover moment. Okay, got it? So this is how we define carryover moment. Okay, how do you calculate carryover moment? Let us see that. Carryover factor. Okay, so that is carryover moment. A carryover factor means what? It is simply the ratio of m dash by m. Means what is the value of carryover moment, that is m dash value, divided by what is the applied bending moment, what is m. Okay, that ratio. So this is applied and how much is developed here. Applied at one end and developed at the other end. So the carryover moment divided by applied moment. Carryover moment, COM, what we call carryover moment. Okay, so carryover factor. Carryover factor. So carryover factor is equal to carryover moment by applied moment. Okay, so that is the information regarding carryover moment. What is carryover moment? Why it comes? And what is carryover factor corresponding quantity? Okay, so once again, carryover moment means the moment developed at far end of a member fixed at one end and hinged at the other end. So when we apply some moment at hinged end, the moment developed at the fixed end when the far end is fixed, that is called as carryover moment. Okay, right. So what is carryover factor then? The carryover factor is called carryover moment divided by applied moment. Okay, so carryover factor means carryover moment divided by applied moment. That is called as carryover factor. So these are required for your moment distribution method, right? So this is regarding carryover moment. So we'll come back to the next session with another quantity. Thank you.